how many of you loves Lego? Yeah, most of us love Legos, and we can build, make, play with it. At the same time, Lego has many different pieces that allows us to make different models or creations. The same way, we also can look into how Nix is set up in that way. So ever look inside Nix store and felt immediate confusion? You are not alone. I've just begun my journey into learning Nix. I just checked my first commit of my Nix configuration. It's like April 22nd last year, so I'm fairly new. So this talk is also aimed towards people who are getting started to use Nix and would like to understand how the Nix store works. Okay. So for many, the magic of Nix hidden behind the cryptic hashes and the mysterious derivations. So this talk will strip away the jargon to explain how Nix works using a simple metaphor, a giant immutable Lego set. And we will explore how Nix builds software in total isolation, why your system wouldn't just break like traditional, conventional distros, and how every package is just a recipe waiting to be snapped into place. And just a disclaimer, this talk and myself are not sponsored by Lego. Just to make sure. Okay, so for example, if you look into Nix store, we see this cryptic hash, program name, and the version. So I myself, when I got started, I was like clueless. What does this mean? It looks random and the structure seems like opaque. This is my reactions. What are these hashes? Why is everything immutable? Where's my user bin? So, we know that conventional package managers hide the complexity behind familiar directories such as user bin. But in Nix approach is that it does the opposite. It shows us everything. So at the first glance, it seems like it's overwhelming. It's like chaos. So here's a rough overview of what we're going to touch around during this session. First of all, we're going to explore the Lego metaphor in explaining Nix store. Next, we would look into Nix expressions and derivations. And the final smaller part is that how we can see that to use Nix in our practical day-to-day usage. So now this is a key metaphor that will help, hopefully help to make Nix store more understandable for people who are new to Nix. Oops, sorry. So conventional package manager are like throwing all your Lego bricks in a huge bin. Everything is mixed together, and packages share the same directory, such as user bin. So two versions of the same library compete for the same path. So sometimes it gives like conflicting dependencies, or even, all this dependency health. And if you were to upgrade a package, so replacing this shared dependency can easily break other packages, knowingly or unknowingly. How Nix does is that Nix builds in isolation, so upgrading one package never touches the another files. And it's hard to undo changes. Once you install a package, it exists in your system path now, or the common path. And as we mentioned, dependency management could be very, very tricky in this regards. Now, here is the key metaphor that I'm going to use. Remember how, remember a giant a box of Lego. You have a Lego set. In the box, you find the pieces of bricks, and you have your instruction booklet, isn't it? Compare it to the Nix package. The binaries and libraries are like a set of bricks. And the derivations that builds it, it's like a Lego instruction manual. And the content address hash is like a unique set number. So in Lego, you can snap bricks together perfectly, and the instructions, as long as you have the same bricks, you should be able to build the same model exactly the same way. And once you build it, usually for adult fans, they would put it on display, nice, on the cupboard with LED lamps, and you can always combine sets safely. And usually we don't modify the build set when we put on display. The same rules that when we work with Nix, we would have this same concept in mind. So now we'll go into the more meaty part of the talk. We'll look inside Nix expressions and derivations and how this relates to Nix store, so that you get a better understanding on Nix store works. First of all, what is a Nix expression? A Nix expression is just a declarative source code written in the Nix language. You describe the inputs, the build steps, and the expected outputs. So Nix expressions are pure functions, meaning that the same input always produces the same results. And the Nix expression file is the file that you edit as a developer. So expression declares what to build, but not how to run it. As a recap, what is an expression? Just imagine that the expression is like the Lego model that you sketch on paper. This is the first step, you sketch on paper. Now, in order to translate the Nix expressions into derivations, Nix evaluates the expressions to produce or realize derivations. The derivations is fully resolved build recipes with every dependency pinned to an exact store path. And we will explain store path more in details in the later slides. This is a very important distinction in Nix. You write expressions which are human-readable source code, and then Nix turn these expressions into fully resolved machine-readable build recipes, and which we call derivations. So in this process, when Nix translate or turn these expressions into derivations, in the Lego metaphors example, so it's like, you have the sketch just now that you have sketches out. So Nix would read the sketch and then print out the instruction manuals on how you build it. And what is a derivations? A derivations is just a recipe. It tells Nix exactly what inputs are needed, which steps is to perform, and what is the final output should be look like. So, back to the Lego metaphor, a derivation is like the Lego instruction manual that comes in your Lego set. Everyone follow along? Good. Now, this would be a huge chunk of code, but don't worry, I will explain it blocks by blocks. This is an actual example of a Nix expressions which run a date command from the Rust version of the core utils to print out a UTC date time. So don't fret, I will go through it piece by piece. So at the top part, you will see that we have to declare the inputs. So, every Nix file is a function. Here, we can see that the question operator means that if a default value, you give a default value if now, which means that Nix would say, it means that this line says that we give Nix a package set, or else Nix would find the Nix package set that he could find in the given context. And this is how the expressions know where to find its dependencies. It's like the shopping list before you start building. So declaring inputs is like finding the bricks that you need in the Lego catalog, if you follow along the Lego metaphor. Now, the second part is that choosing the builder. So here, we use the run command, which is the simplest way to create derivations. You give it a name, declare which tool you need at build time, and produce a build script. The name here you choose, which is after the run command, you see I put in quotes, show UTC date time. That is the program name that would appear after the hash in the final store path. And the native build inputs is the dependencies available to the derivations build process. And an important note to on this stage is that Nix is always, you have heard, Nix is always guaranteed that whatever you wrote there, it's immutable, it's always reproduce the same output. But there's a catch, which my friend Christian Chavez nitpicked me, which I appreciate. An important note to that is that if you use a non-deterministic string after the show date time, this would never be reproducible or create the same output every time. For example, if you quote show date time and then cat def-u random, so every time you run this build derivations, it will produce a different path. So just a tiny nitpick. So Nix is not a guarantee for reproducibility, but it has a very strong guardrails to ensure that software is built as reproducible as possible. Okay? So, and then the third part is the actual build logic. You can see that how we use a placeholder $out. That would be interpreted by Nix in the later stage, and then it would realize the path using an absolute path to the dependency pointing to the Nix store. So in this build script, you can see that there is no reliance on system path or system-wide binaries. Everything is built in total isolation. Now, we'll go a bit deep into, a bit more on explaining the string interpolation. Remember this, this dollar variable. So when Nix replaces the string interpolation expressions with absolute paths to the Nix store, this resulting, the script would not depend on any system path. So it would point directly to a specific version of bash and a specific versions of co-utils, for example. So if neither the dependency changes, the hash changes, and you will get a completely new path. And you can see in this example, you know, the $package runtime shell, it translates to a fully realized store path. So now we will look into how the build process from the Nix expression file. So during the build process, first Nix would evaluate the expression to get the deviations, and then Nix would execute the deviations in a sandbox to produce its output. So it would, so the first step is that Nix would try to realize the deviations by ensuring the store path is valid. So what does this mean? So if we build this expression on another machine with the same Nix packages version, we are absolutely guaranteed to get the exact same hash. So this is really strong reproducibility. Now, the first thing when we run Nix build, using this Nix build file, the Nix expression file, so the first thing you would see the output is that which deviations it plans to build. So the deviations is the file that Nix would interpret and use to build the output. The content address hash encodes every input, including the build script, dependency, system architecture, for example, and then would create this hash, content address hash. And further down the build output, you can see that Nix would check the binary cache before building anything. Since someone else has already built the core utils with the same exact hash, Nix download the pre-built version. And how does this benefit us? It saves a tremendous amount of time in using the same exact version of the program. Without the cache, I would actually need to compile the entire core utils from source code again, which, it's a longer process. Now we can see that how Nix actually building or by executing the deviations. It runs the build script in total isolation in most cases, and the only tools available in that is what we declare in the native build inputs variable. That is why Nix is reproducible. And if you see that everything is built in the sandbox, so nothing from the host system can leak into the build process. And this is just an optional visualization tool during the build process. If you use the Nix output tool, it will give us a clear picture of what happened. As you can see here, the show UTC datetime was built locally, and since the core utils is already in place in my local Nix store, so nothing is needed to be downloaded. So it's a really, very quick process. Now, we'll now look in a bit more in details about the structure of the deviations file. The deviations file is actually what Nix executes. It contains the fully resolved build recipe with all the store paths being realized. The output section tells us exactly where the build results will land. Both deviation hash and the output hash are deterministic. Also, inside a deviation file, we can see that even the shell that runs the build points to a specific immutable store path. Nix does not use /bin/bash from the host. It uses its own specific specified bash that is locked to a specific version. And the argument that points to standard amp setup script is configured the build environment before running our build script. So every path is absolute if you go through the deviation file. Nothing comes from the host system. And now we'll see that input deviations form the dependency graph. Each one of the input dependency must be available in our store before our build can start. So notice how standard amp is an input, although we did not declare it explicitly. The run command function is a helper that added it for us. That's how Nix ensure complete dependency tracking. And if you see this full block, so this is the fully expanded version of our build script, and compare it to the version that you saw earlier. Remember the $out cat? So you can see that inside the expression, every Nix interpolation has been replaced by a concrete store path. This is the script that Nix actually executes in the sandbox. So the system field would tell that Nix that this is the platform we are building this artifact against. And if we have completed the build step, we can actually examine the output. So in this case, the output is a clean directory with a single executable. And looking inside the script, at the bottom part, you can actually see that every path that in that program points to an absolute store path. So there is no ambiguity which bash or which date command it runs. This is what makes Nix packages self-contained. And the result symlink is a convenience for us because it points to the immutable store path. You can copy the entire closure to another machine and it will produce the same output. So it actually kind of remove this, it works on my machine, surprises. As you can see here, if I'm running directly using the store path or using the result bin command, it's pointing to the same thing for this example. So build process in a nutshell. So just a short recap. Nix evaluates your Nix expression to produce or realize a derivation file. And the derivation file is then interpreted and executed in a sandbox to produce an output in an isolated environment. So everything here is deterministic and traceable. Everyone follow along? Good. Now, a bit more about the store path, which if you were to take away one thing from this talk, this is it. Okay? So think of a store path as an opaque, unique identifier. The only way you obtain a store path is by adding or building store objects. A store path is always reference exactly one store output. As you can see in this example, you have this 32 ASCII characters digest or 20 bytes for identification, and you have a program name and the version. So this forms the store path. The hash isn't random, it's deterministic. It's computed from all the inputs, the build recipes, and the compiler version. So if you change any single of the dependency or variables, you will get a different content address hash. And we will not, we'll go into later slides. So the store directory, if you can see here, it's point to /nix/store. So in most cases, on our machines, it defaults to /nix/store. But in principle, your store directory is arbitrary. You can actually modify it, but we are using a default example, so let's treat it as /nix/store. So a store path is rendered to a file system path as the concatenation of the store directory, which is typically /nix/store, and a path separator, and a digest in that is rendered or calculated in Nix32 calculations, which is a variant of base 32. I'm not going into details of it, but if you are interested to how the hash calculation, the Nix manual has a full explanation on the Nix encoding and also the store path calculation. And it's followed by a hyphen and the name and the version. So this is also quite important. So yeah, everyone got this point? Good. And why hashes matters, as you can see. So it gives us reproducibility. It ensures that whatever inputs that you give is given would produce the same output. And by that, when you know that if you have the same input, that you can create the same output, you can actually enable caching. So if someone else on their machine or from their caches has already built it, you can actually reuse that binary, which saves time. And isolation, different versions coexist peacefully, and also atomic upgrades. And yes, that's why Nix system is so stable. You never modify existing software. Instead, you are creating new versions alongside the new one, the old ones, sorry. I see that I'm running out of time, so do you want me to continue or should I stop?
Maybe we could open up to questions, you think?
Sure.
I'm going to do the Phil Donahue thing if anyone knows who he was.
Thank you. This helped to clarify a lot of the language and how it's organized. You had a comment about if you copy the full closure to another machine,
Yeah.
it will run as is because it's all addressed based on the contents. But what does a closure look like compared to a derivation or an output?
Yes, I actually have a slide on closure. Yeah. This is the latest slide. So you have reference and referees that you can actually check the dependencies and also closures. So a closure would mean that a package with all its dependencies resolve recursively. So you can see that when you try to calculate a closure, it shows you whatever a dependency it needs. So this is the thing that you need to run the program. And a closure would mean that this is a Lego set that is completely built that you can take to display and use it.
Any other questions? Okay.
How does the Nix system know if it can let go of a build package?
Let go of a build package.
Yeah, I thought that there was some way to clear it out.
Yes, there was a slide on garbage collection too. I'm so sorry because Nix store is such a huge topic, and yeah. So just a short mention about garbage collection. So if you're using Nix Darwin or Nix OS, you can actually configure a garbage collection that runs like every week or every day, depending on your choice. And how Nix does is, if I remember correctly, is that it would check. It has a SQL database that tracks all the store path, and whatever that is orphan, that is not referenced by anyone, Nix will actually mark it as orphan, and then when you run a garbage collection command, it will actually remove from the store.
We got maybe one more minute before I have to shut it down. Any other questions? Okay, thank you all. Leonard, thanks so much. That was great. I appreciated that. Yeah, learned a lot.